Okay. So today we are going to see the key terms used in Kafka, and those key terms will be very frequently used as we go ahead. And whenever we talk about the Kafka, we will use those terms. That Kafka is an event streaming platform. Event, if not event, I haven't used this word event till now, but it's basically event streaming platform. So event is nothing but it's a data.
Okay.
In simple language, event is nothing but a data. So what happens is, suppose you go to any website and you click on some button, that is an event. If you scroll a page, that is also an event. So whenever you do something on any website, any kind of activity, that activity is called event. And as part of that event, what happens? That website will generate some data. Okay. So in Kafka language, whenever a data is generated out of any application or data is produced, that's called event. So when the definition is saying it is event processing platform, it means it will process the data, nothing else. So Kafka is a event processing or data processing platform used to collect, store, and process real-time data streams at scale. Okay. So now, what do you mean by streaming? That is the basic question. So streaming is nothing but whenever data flows.
The slide. The slide is still on the first slide itself. I think you have moved the slide.
Yeah. I'm on first slide only. I haven't.
Oh, okay.
Scrolled. So streaming means when your data is flowing, that is called streaming. It's a continuous flow of data is called streaming. Streaming means when your data is flowing, that is called streaming. It's a continuous flow of data is called streaming. So Kafka will collect that data stream and it will store it and it can also process it. So that it can further be sent to any other application. Okay. And obviously yesterday we discussed multiple times that Kafka is able to scale. It can increase as per the load. Okay. Are you able to see the slide change now?
No, it's on the slide 1.
Still on slide 1? Okay.
Yeah. I think it's taking some time.
Okay. There might be some lag, not an issue. Let me know once you are able to see the second slide. Yes, that one only. Okay. Good. So this is just a diagram which is telling you that the box in the center is Kafka. This black box. Okay. And this is the icon of Kafka. Wherever you will see the Kafka thing, you will see this is the logo of Kafka. So all other things around this rectangular box, those are the applications, different applications which can produce the data. So those applications will.
Kafka is installed on a server. That symbol denotes the server. Or yes. It's just an application.
It's a server actually. Kafka is stored. It's a piece of software which you will store on a machine.
Okay.
Simple. So whenever we need Kafka, we have to create a machine hardware. Whenever we need Kafka, we have to create a machine hardware, and on that particular hardware, we have to install the Kafka. Without any machine, obviously, we cannot run anything. So basically, Kafka is nothing but a software only, but that software need hardware also to run.
Okay.
So. Yeah.
On-premise only, no cloud such things. Kafka will be installed.
Okay. Can you repeat your question? What was that?
The Kafka will be installed on the system only. No, it can't be used on the cloud.
Yeah, we can install it anywhere. See,
Okay.
cloud is also nothing but it's kind of infrastructure only.
Mm-hmm.
You don't have to manage anything. That is what cloud is all about.
Mm-hmm.
Wherever we suppose, let's take an example of AWS, Amazon Web
Okay.
Service. So it's
Mm-hmm.
nothing but a cloud platform. So suppose you want to buy some space, or if you want to buy any machine, then what you will do, you will pay it and they will provide you the machine over the
Yeah.
cloud. So you will host your application on that machine, but you don't have to worry about where that machine is located, how how they are working, how they are attaching the hard disk to that machine. That you don't have to worry about. So that is the thing. So irrespective of whether you have the machine or you are depending on any cloud service provider, ultimately this Kafka has to be installed on some machine.
Okay.
And again,
Yeah.
so so this diagram is very simple. It is simply depicting how different applications around the world generating data, and that is pushed to Kafka. This is the current situation in this world. There is, as I said yesterday, there is no application uh, in this world which is running without Kafka, because almost all the application produces the data and they have to transmit that data to some other application or process that data very fastly. So Kafka is the best solution. Okay, let's move ahead. Now, just now I said event. Kafka is event processing or event stream processing platform. So now let's further dig into event. What exactly the event? So just now I said event is further dig into event. What exactly the event? So just now I said event is simply a data. Now I will further demystify this term. So when we say an event is just a thing that happened, event is combination of two things: notification plus state. Okay, example I gave: user clicked on a link on web page, or an invoice becomes past due, a program writes some output to a file. So these kind of activities are called events. So I think Jagdish, you might have heard this term earlier also.
Even sir.
Yeah, event in a generic way.
Yeah, like log events like that.
Yeah, yeah, right. So
Yeah.
event could be anything. So
Mm-hmm.
basically, it's nothing but a combination of two things: notification.
Like that.
Yeah, yeah, right. So
Yeah.
event could be anything. So
Mm-hmm.
basically, it's nothing but a combination of two things: notification and state. So,
Okay.
whenever you do something, something will happen, and the state of that particular uh, object will change definitely. So that is the output of any particular event. Whenever you
Okay.
do something, data will be generated as well as the state of that particular object will change, right? So now we are simply talking about the event which is generating in the Kafka. So this thing you keep in mind whenever we say event. So in Kafka, event consists of two things: identifier through which you can identify that particular event, and value is the actual data. Okay.
Okay.
So whenever an event is generated, it has two parts. One is key, another one is value. Key is nothing but a identifier or ID of that event through which you can easily identify that event. Okay. Suppose there are thousands of events, but you have to identify any particular event. So you should have the ID of that event. Then you can easily identify it. So that is called key. And the value is the actual data which you are going to store in the event.
Okay.
Okay. So again, I'm giving you a very live example. Suppose you are uh, clicking on any particular button. Suppose play button. Play button in the web to play button in the web. to play a song, suppose. So what will happen when you click on that play button, the song will start playing. So suppose that application is using Kafka. So what it will do, it will generate the events, and those events, what will do, they will send you the data in the form of MP3 song, right?
Okay.
Next, this I just now explained. It could be primitive type like string or integer. Key could be anything. Key could be any string also. It could be integer also. Okay.
Sorry, like the slide is not changing. It's on the third slide.
Just wait a moment.
It's still on the world produces data.
Oh,
Produces data.
okay. Let me see what happened.
Okay.
Again sharing, and you can let me know if you are able to see. Are you able to see now?
Yes, yes.
Okay. So this was the first slide. Second slide, I would say. This is the event I was saying. Event is the combination of two things. How your event will look like whenever we will talk about event in Kafka. Now, event has a key, as I said, so key could be anything. Key could be a string, or it could be integer, or it could be any combination of string, integer, or special characters. Okay. And value will be the actual data. Okay, that's why I'm saying it is the actual domain object. So data could be anything depending on the type of application you are using. If you are using Netflix, for example, so it will be video data, obviously. If you are using any tutorial website, it could be text data.
Yeah.
If you are going to any MP3 song website, obviously it will be MP3 data. Okay. If you are watching any picture on the web, so it will be your JPG data. So value could be depending on the data which you are consuming.
Okay.
Okay. So next thing is, now whenever I will say event or data, always you can assume that both are the same thing in Kafka. Okay. And you also imagine that it will be a combination of key and value. Okay. So this you have to keep in mind. Now we are going to talk about what is the difference between queue and topic. So yesterday I told that whenever we want to send any data, we need a queue. You remember?
Yes, yes.
So what will happen? Producer will send the data to queue, consumer will read the data from queue. Okay. So queue you might have heard, but topic is something new which you might not have heard. So what is the basic difference between queue and topic? So if I say logically, then there is no difference. Queue and topic will behave same way. In queue also you will send the data, in topic also we will send the data. But in Kafka we always talk about topic. There is no concept of queue in Kafka. Okay. So topic is a term which is used in Kafka instead of queue. I'm showing you this difference between queue and topic. What is the difference? Why we are not calling it queue? Why we are calling it topic? So the first difference is message-oriented middleware that holds the message until receiver is ready. So in queue, what will happen whenever you send the data, producer has to wait whether receiver is ready or not. If he is not ready, then producer cannot send the data. Okay. So message-oriented middleware that holds the message until receiver is ready. So what will happen when you send the data to any queue, it will stay in the queue, and then it will hold the data till the time consumer consumes it. Okay. Whereas in case of topic, message-oriented middleware that is responsible to hold data and delivers message to subscriber. Okay. So the receiver and subscriber both are same. Whenever we talk about Kafka, we will be able to hold data and delivers message to subscriber. Okay. So the receiver and subscriber both are same. Whenever we talk about Kafka, we will always call it subscriber. We will not say it receiver. That is the term. Yesterday we discussed already. So here we don't see any difference. First difference is common. Whenever we send the data to the queue, it will be sent to the receiver. Whenever we are talking about normal legacy queue like RabbitMQ or ActiveMQ or IBMQ, when we talk about Kafka, we will call it a topic. Okay. Now, in point-to-point messaging, the sender stores the message on the queue and the receiver reads the message from queue. In publish subscriber messaging, the sender stores the message on the topic and topic delivers the message to subscriber. Okay. Here also both the things are same, just the terms are different. Here we are calling them producer consumer. Here we are calling it publish and subscriber. Now third one is queue works with one receiver. Topic works with multiple subscriber. That is the main difference here. So whenever you will send the data in queue, what will happen? Only one consumer can consume it. Okay. If there are two consumers, then if suppose one consumer has consumed it, then second consumer cannot consume that data because that data is deleted from the queue. Okay. But in case of topic, that particular data which you send to the topic, that can be consumed by more than one consumer. That will regular time. Default period for data retention in topic is 7 days. Okay. So that is one of the major difference. Queue will never delete the data. Queue will delete the data as soon as it is consumed, whereas topic will retain the data for a particular time interval. It could be 7 days by default. And you can also configure it to 1 month, 2 months, 1 year, 3 years, as per your convenience. If you want to keep that data for a longer duration. Okay, so that is the basic difference.
So normally here in Kafka, publisher and the subscriber is a part of Kafka, or publisher is its own system and Kafka is the center and the subscriber is the receiver. That's what you're saying. Publisher is a center and the subscriber is a receiver. The subscriber is a receiver. In between, we have a Kafka to process, to stream the data.
Exactly, you're right.
Okay.
Producer and consumer are not part of Kafka.
Okay.
Let's move ahead.
Yes.
Okay. So again, here we are showing it in the pictorial form. What is the difference between queue and topic? So this upper part you can see, sender is there on the left hand side. It is sending the data to a queue, and you can see on the right hand side there are two receivers. Okay. So only one receiver can read that data. So you can see the bottom receiver has received it. So top receiver will not read the data because that data will be deleted from the queue as soon as it is received by one receiver. Okay. Now, as soon as it is received by one receiver. Okay. Now, second example is topic. Here, publisher is sending the data to a topic, and that data can be consumed by more than one receivers. Here we are not calling it receiver because subscriber is the standard term which is used. And so this clarifies the difference between queue and topic.
Yeah.
Okay. It's a very common interview question also, Jagdish. They will ask you what is the difference between queue and topic. Okay. So you will say there is one common difference in queue. When you put the data or you send the data, once it is consumed, data will be deleted. Whereas in case of topic, when you send the data, it will stay there for a longer period. And let's move ahead. Now these are the fundamental terms which we have to discuss. So you just read it once, the list, complete list.
Okay.
I think most of the things you already, not most, few terms you have already heard. Like first one is producer,
Producer, consumer,
consumer,
topic,
topic,
partition,
partition, replica,
broker, clusters, leader, follower.
Yes. So these are the 9 fundamental terms which we will be using in Kafka again and again. And because we are creating a base for the Kafka, we are learning the fundamentals of Kafka. So you have to understand each, and we are creating a base for the Kafka. We are learning the fundamentals of Kafka. So you have to understand each and every terms mentioned here. So let's start with producer. So we know what is the producer. We call it producer because it is generating the data. Simple. Second term is consumer. Sometimes people call it subscriber also. So consumer and subscriber both are the same thing, synonym. And subscriber is the one which consumes the data from Kafka. Okay. Topic. Topic is nothing but it's the place where the data actually is stored.
Okay.
Just now we saw topic is similar to queue, but it has a basic difference, very basic difference. It can store the data for a longer period. Store the data for a longer period. Now, so first 3 terms, I don't think any confusion.
Yeah. It's clear.
Okay. So now we have 9 slides now. Each slide is explaining each fundamental component. So 3 things we have already seen. Producer. So this is the producer. Left hand side you see there are many applications which are producing the data. So these applications are called producer. For example, we use Uber, Ola, right? So Uber, Ola, these devices, Uber and Ola, these applications use the GPS whenever we travel, and it shows the location of the traveler as well as example of Kafka producing data. And then it writes the data to the Kafka on the right hand side. And you can see there is one arrow, and on top of that arrow we have written write, and in the bottom we are saying ACK and ACK. So ACK means acknowledgement. So whenever we producer send the data to Kafka, okay, it will get the acknowledgement also. The producer can get the acknowledgement also. Okay. But it is not compulsory. It's up to you. If you want the acknowledgement, you can configure it. If you don't want any kind of acknowledgement, you can disable it. Okay. So acknowledgement. Acknowledgement. I think Jagdish, it's very normal term. Suppose if I'm sending you something, suppose I'm yeah, it's kind of parcel only. So if I deliver any parcel, if you get the receipt of it, that yes, it is delivered, it is called acknowledgement. Second term is consumer. So in the previous diagram, you saw producer sits on the right hand side of the Kafka. In second side, consumer always sit on the left hand side of the Kafka. Okay. See, physically they can be any on any side, left and right. It doesn't matter. But just as a sake of imagination, you can consider on one side there is producer, and another side there is a consumer, and in between, consider on one side there is producer, and another side there is a consumer, and in between Kafka is there, right? So in the previous slide, I showed this is the Kafka. In the next slide, again this is Kafka only. Just in between, I'm showing here there will be brokers also inside this Kafka. So for the time being, you can ignore this broker. Okay, I will explain what is the broker. Broker is nothing but the actual machines which are running the Kafka.
Okay.
Okay, so even if you are not able to understand completely why these small boxes are there, you can consider it similar to this box. Okay, you see here.
Okay.
So again, when we talk about consumer or subscriber, obviously consumer will pull the data applications. So obviously destination applications will be kind of pie chart you want to prepare using that data, or you want to create any dashboard, or you want to analyze that particular data, or you want to further process that data. So these are the use cases of consumers.
Okay.
Let's move ahead.
So in the picture you showed like multiple systems we can install Kafka in the same cluster.
This one?
Yeah. Okay.
Yeah. So because you are from infrastructure background, so it will be very easy to you to understand how the cluster look like. So there will be obviously Kafka is, so it will be very easy to you to understand how the cluster look like. So there will be obviously Kafka is reliable system, so there will be more than one machines, and they will be connected to the network. Each machine will have a hard disk. So here in the corner you can see it's a cylinder. This is nothing but it is representing one hard disk attached to it.
Hard disk.
Yeah. So anyway, we will see this broker in detail. This is just a picture. I will cover every term, everything in detail.
Sure.
So consumer is done, producer is done. Next is topic. This also done. It is a topic is the place where we store the data. So a stream of messages belonging to a particular category is called topic. Now, this is a simple. So if someone asks you what is topic, so you can give this definition: a stream of messages belonging to a particular category is called topic. Data is stored in a topic. So now how this term is derived, topic. We could have called it anything else. Why we are calling topic only?
Like it's a database or just
So, if I ask you this question, what is the generic meaning of topic?
it's a topic is a heading like.
Yeah, so we know topic means we are discussing. If we talk about any particular subject, then it is called topic, right?
Yes.
Will be car. If I'm talking about any movie, my topic is movie. So, but in Kafka, why we are calling topic? Why we are not calling it queue? So the reason for calling it topic is each and every queue in Kafka can hold on only particular type of data, particular category of data. It's not possible that you are sending any type of data to a single queue. So suppose I want to send data related to movie to a particular queue, then that topic name should be given as that queue name should be given as movie. Okay.
To categorize things.
Hmm?
To categorize
Yes,
things, data.
exactly. You got the point. So in Kafka, because we are categorizing the data, which is going. So in Kafka, because we are categorizing the data, which is going into the queue, that's why we are calling it topic instead of queue.
Okay.
Okay, so that is the another reason why we are calling it queue. First one is it can retain the data for a longer period. Second one is any particular topic can hold only a specific type of data. If you want to store second type of data, you have to create a second topic. If you want to store the third type of data, you have to create a separate topic, third topic. Okay. So in Kafka, it is not. It is never used in the industry that same topic is used for all type of data. Okay. Always you will create a unique topic for that particular type of data. So I give you example of my application in Geo. So there are some 13 topic, and each topic is dedicated for special type of data.
Okay.
All right, let's go ahead now. What is partition? So now when you divide a topic into further small blocks, that is called partition. The topic internally is divided again. So each division is called a partition. Okay. So that is again a logical thing. Physically, obviously, you cannot see the topic. Physically, you cannot see the partition. But logically, both are logical things. So when we say partition, it is nothing but dividing a topic into more small. The topic name is car. Again, inside that car topic, there could be multiple partition. 2 partition, 3 partition, 40 partition.
Okay. Like number of brands.
Number of brands you can consider it, but that may not be the right example. So the reason for creating the partition is so that more consumer can consume the data independently.
Okay.
That is the purpose.
Yeah. Understood.
So for example, there is a topic and there are 10 consumers. So obviously, if we don't create the partition, then all consumer will race with each other. Each consumer will try to access the data, which might cause conflict. So, or one might have to wait while another one is reading, or access the data, which might cause conflict. So, or one might have to wait while another one is reading. So to avoid that, we want the consumer to read the data independently or parallelly. So that's why we have divided the topic into partition.
Okay.
That is the main reason. Other reasons also we will discuss further, but that is the main reason why we create the topic partition inside the topic. Next, replica. Replica is nothing but whenever we create the partition in the topic, then we have to create a backup also for that, so that in case of any untoward incident or in case of any disaster, we can easily recover the data. So that is the replica. It's a copy of the part, and always remember that whenever we write the data, it will never be written to the actual. It will never be written to the replica. It will always be written to the actual copy.
Okay.
And whenever we read the data, that time also it will be read from the actual copy. It will never be read from the replica. Okay. So read-write operation always happen in the actual copy, not the replica.
Yeah. Okay.
Okay. So the only purpose of replica is to prevent the data loss in case of any disaster. Read-write will never be performed on that replica. Now, one question might come into your mind, then how the data will be updated, or how
Updated in
will
replica.
how will we see the latest data? So a replica will be actually, again, it will be running in a node, or replica will be running in a machine. So that machine will time to time get the latest data from the actual copy and update its state.
Okay. Right. Understand.
Okay, let's go ahead. So now we will discuss about broker. So till now all the terms are clear. What are the terms we discussed? Producer,
Producer, consumers, topics,
consumer, topic, partition,
partitions, replica.
replica. Okay. Now comes the broker. So broker is nothing but these are the machines which will be storing your data, and these machines will definitely be having some hard disk. So you see this middle box, Kafka is there. So this big box is nothing but the Kafka. Inside that bigger box, there will be multiple machines, broker 1, broker 2. Each machine will be called a broker.
Okay.
So
In
these
each
are
machine, Kafka is installed.
yes, exactly. So these are the machines where Kafka will be installed, and these machine will be connected through network, and each machine will be having one hard disk, and the hard disk size will be very huge in TBs,
Okay.
petabytes in T. Okay. So these are called the brokers. Simple. Okay. And obviously, I said Kafka can retain the data for a longer period of time, so there will be a retention time also. So whenever we install the Kafka on these machines, we will configure the retention time also. If you don't configure it, default will be 7 days. Clear?
Okay. Yeah.
Now Kafka cluster.
Producer and consumer, we have a broker.
Producer and consumer, sorry.
In between the producer and consumer, we have a broker.
Exactly.
Okay.
Kafka cluster is nothing but the collection of brokers. Simple. So whenever we will start the lab sessions, we will create at least 2 machines to create a cluster. Single machine will never create any cluster. So you need at least 2 machines to create a cluster. So that we will see. Leader. Leader is a node which is responsible for all the read-write operation. So node and machine both are same thing. Node, machine, broker. These will be synonym. Whenever I'm saying node, it is nothing but a machine. Whenever I'm saying machine, it is nothing but a broker. Okay. So all 3 terms I will use interchangeably. So leader is the one who from where you will perform the read-write operation. So just now in the previous slide I said replica will be there. So replica can be stored on the same machine, or it can be stored on the different machine. But read-write operation will always be done from the actual copy, I said. Right? So leader is the machine where you will store the actual copy. Got it?
Okay.
Okay. So you will create a topic first, and obviously topic will have a partition, and each partition will have a replica also. So there are suppose 3 partition of a topic, then 3 replica will also be there, and each replica will be stored on some machine, obviously. Then 3 replica will also be there, and each replica will be stored on some machine, obviously. So leader will be the machine which will storing which is having the actual partition.
Okay. So then what's the difference between the broker and the leader?
No difference. Leader is also a broker.
Okay.
The only difference is normal broker and the leader is normal broker will store your replica, whereas the leader will store always the actual copy of the that particular partition.
Okay.
Clear?
Yes.
So here, 2 points I have given. It's a node response to keep in mind. All the read-write operation will always be done on the using the leader machine. Okay. And every partition has one server acting as the leader. Okay. Second one is follower. So it is just opposite of leader. Follower is the machine which will host the replica, and it will follow the instruction of leader, and time to time it will talk to the leader and get the latest data and update. Okay. So by the time you have understood that replica is associated to follower and
actual data is associated to leader.
Yes. So node which follows leader instruction is called follower. When leader fails, one of the automatically become the new leader. Now this is very important. So we know that Kafka is nothing but is a collection of machines, and machines can break down. Machine might fail. So that's why we are creating the followers. So as soon as the leader machine fails, follower will be elected automatically, and that will become the leader.
Okay.
And this is very important concept, and that's the reason we are creating the replicas, we are creating the followers. Third one is follower pulls message and updates its own data store. This I already covered when I said how it will update the replica. So time to time it will pull the data from the master or leader and it will update.
Okay.
So that is all. These were the terms which I wanted to discuss with you for today. Any questions? Because now we have 6 minutes left, so I want you to ask the questions. Any kind of doubt, I'll be happy to answer. But you have to memorize these concepts. You have to imagine these concepts very clearly. If you don't understand these concepts clearly, it will be very difficult to go ahead. Okay, or you might get confused in next sessions if you don't have clear understanding of these components.
Okay. Yeah, it was clear. No issues.
Okay.
Theoretically, it is clear. Like when we see it practically. Theoretically, it is clear. Like when we see it practically.
Yeah. Practically, I will show you. But theoretical concepts, we have to be very clear. Then only we can crack the interview questions. Otherwise, fundamentals will be strong only if you understand these terms.
Like creating partitions in the topic, like that.
Yeah, that
I can understand what is partition, but creating partition and all, we will only when we see we will get some.
Yes.
Yeah, I understand.
Okay, that's great. So what is the default retention period of a topic?
7 days.
Okay. What is the basic difference between topic and queue?
Like in queue, data will be deleted in several days, and in queue it will be like one-to-one receiver, and in topic it can be one-to-many receivers.
Correct. So simple one-line definition will be in queue, data will be deleted as soon as it is consumed. This is the complete sentence.
Okay. It will be deleted as soon as it consumed.
Yeah.
Okay.
Whereas in topic, even if the data is consumed, data will remain.
Yeah. Okay.
Okay. What is replica?
Replica is a copy of the actual data. It's stored in another machine.
Correct. You can say more precisely, replica is the copy of the partition.
It's stored in another machine.
Correct. You can say more precisely, replica is the copy of the partition.
Okay.
Okay. We never create the replica of topic. Replica will always be created of a partition.
Oh, okay.
Okay.
It comes from the partition. Okay.
Yes. Yes. So suppose you have a topic called car. Car is a topic name, and it has 3 partitions. How many replicas will be there?
3 replicas.
3 replicas. Okay.
Yeah.
Now, minimum 3 replicas are required, but it is not limited. It's not like you can get more than 3 replicas also. So it is not compulsory, but at least bare minimum you need 3 replicas because 3 partitions are there. But in actual world, people create more replicas than the actual partition. So there are 3 partitions, but there could be 5 replicas.
Okay. But minimum it should be 3.
Yeah, minimum it should be 3.
To make the work easier, you can create more replicas.
Yes. So suppose you want double type of surety, then you can create 6 replicas. 2 replicas for each partition.
Yeah, I understand.
Okay. If you want 3 times of security of your data, then you can create 3 multiple replicas. Like 3 partitions are there, then 9 replicas you can create.
Okay.
All right. So broker. What is broker?
Broker is a place where we can store data from the producer. Producer sends the data to the broker, and from the broker, data is sent, consumer retrieves data from the broker.
Great. Okay. So, and where your topic will be created, inside the broker or outside the broker?
Inside the broker.
Great. Right. And where the partition will be created? On the broker or somewhere else?
Partitions will be created inside the topic.
Yeah. So obviously these are the final terms. So everything will be inside broker only.
Oh yeah. Oh yeah.
Topic,
Inside the
partition, replica, everything. Okay. So, all right. So you just digest these terms.